Okay, let's have some work example on logarithmic differentiation. We are told to find the derivative of y is equals to the natural log of 2x squared plus 5. Okay, I'm going to give you a formula and I want you to remember it. When we are told to find the derivative of a function that looks like this, len u, the derivative of y is equals to len u is given by this. Derivative of y is equals to, we are going to take the inverse of the inner function. We are going to take the inverse of the function inside the bracket. If you look at this function, the function inside the bracket is u, is that not it? So we are going to take the inverse of u. Then we are going to have 1 all over u multiplied by the derivative of u. You understand? That is how to find the derivative of a function that looks like this. Are you getting it? So let us use the same approach to solve this question. The first step is that we are going to take the inverse of the function inside the bracket and multiply with the derivative of the function inside the bracket. That is how to find the derivative of a natural logarithmic function. Okay, the derivative of y, which is y prime, is equals to, we will take the inverse of this function inside the bracket. That is 1 all over 2x squared plus 5. You understand? Multiplied by the derivative of the function inside the bracket, multiplied by the 2x squared plus 5. Okay, so the derivative of y is equals to 1 all over 2x squared plus 5 multiplied by, differentiate 2x squared plus 5 using the power rule. We are going to get 4x. So the derivative of y is equals to 4x all over 2x squared plus 5. You understand? Okay, let's have another practice question. Example 2. Find the derivative of y is equals to the natural log of x squared. Don't forget that when you are given a function that looks like this, and you are told to find the derivative of such function, we are going to take the inverse of the function inside the bracket and multiply it by the derivative of that function. So in that case, I'm going to have the derivative of y is equals to, the function inside the bracket is x squared. So I'm going to take the inverse of x squared, that is 1 over x squared. You understand? So I'm going to have 1 over x squared multiplied by the derivative of x squared. If you differentiate x raised to the power of 2 using the power rule, you are going to get 2x. So I'm going to have 1 over x squared multiplied by 2x. So the derivative of y is equals to 2x all over x squared. The derivative of y is equals to 2 all over x. You understand? So that is how to find the derivative of natural logarithmic function. Okay, let's have the third work example. Don't forget, we are still going to use the same approach. The first step is to take the inverse of the function inside the bracket. When we talk about inverse, we are talking about the reciprocal of the function inside the bracket. So I'm going to have the derivative of y is equals to 1 over the x squared, x raised to the power 3 plus 4, multiplied by the derivative of what? X raised to the power 3 plus 4. So the derivative of y is equals to 1 over x raised to the power of 3 plus 4 multiplied by, if you differentiate x raised to the power of 3 plus 4 using the power rule, you are going to get 3x raised to the power of 2. So the derivative of y is equals to 3x raised to the power of 2 all over x raised to the power of 3 plus 4. Okay, example 4. Find the derivative of natural log of x raised to the power of 3 plus 4x. We are still going to use the same approach. The first step is that we are going to take the inverse of the function inside the bracket and multiply it with the derivative of the function inside the bracket. You understand? So the derivative of y is equals to the inverse of x raised to the power of 3 plus 4x multiplied by the derivative of what? X raised to the power of 3 plus 4x. So the derivative of y is equals to 1 all over x raised to the power of 3 plus 4x multiplied by, if you differentiate x raised to the power of 3 plus 4x, we are going to get 3x raised to the power of 2 plus 4. You understand? So the derivative of y is equals to what? 3x raised to the power of 2 plus 4 all over x raised to the power of 3 plus 4x. You understand? So the derivative of y is equals to natural log of x raised to the power of 3 plus 4x is equals to what? Is this. So please, I want you to remember this formula. When you are told to find the derivative of y is equals to ln u, the derivative of y is equals to ln u is what? Derivative of y is equals to 1 all over the function inside the bracket, which is u, multiplied by the derivative of u. You understand? That is how to find the derivative of this function. You understand what I'm saying? So logarithmic differentiation, it is very important that you know this formula when you are dealing with what? Logarithmic differentiation. Okay, let's have another work example. The fifth work example, we have find the derivative of y is equals to natural log of 2x squared. Okay, now we are still going to use the same approach. We are going to take the inverse of the function inside the bracket. The inverse of this function inside the bracket is what? The function inside the bracket is 2x squared. So the inverse, derivative of y is equals to the inverse of the function inside the bracket, which is 2x squared. That is 2x squared multiplied by the derivative of the function inside the bracket, which is also 2x squared. Please, are you getting it? Okay, let's proceed. Derivative of y is equals to, now 1 over 2x squared multiplied by, if you differentiate 2x squared, you are going to get 4x. So I'm going to put 4x. Derivative of y is equals to 4x all over 2x squared. You can reduce this. Derivative of y is equals to, if you divide 2 divided by 4, so I'm going to have 2x 2 all over x. You understand?